So in the previous video, we have completed the evaporimeter or the pan measurement method. Now in this video, we are going to start with these empirical formulas. So as I have told you in the previous lecture, these empirical formulas are the formulas which do not have any mathematical derivation. Okay, these are directly derived from the field experiments. Now these empirical formulas in this measurement of evaporation, they are based on Dalton's law. Okay, so they are based on Dalton's law of evaporation. Now what is Dalton's law of evaporation? We have seen it in the evaporation introductory video. That is, the rate of evaporation is directly proportional to difference between saturation vapor pressure and the actual vapor pressure. Okay, so the same thing it is used here. So let's write it down. There are two equations that we have to study in this empirical methods. Okay, so empirical formulas. So the first formula that we are going to see, it is called as Mayer's formula. So write down Mayer's formula. So what is the formula here? The rate of evaporation EL, it is equal to Km into EW minus EA, saturation vapor pressure minus actual vapor pressure, into 1 plus U9 divided by 16. So this is the formula which is given by Mayer. Up to now, whichever examination problems I have seen it in the previous year, nowhere this calculation part is asked. Okay, the questions are asked directly on this, like the Mayer's formula is an empirical formula or a analytical formula. So the name you should remember, that is the most important point from this slide here. Okay, so this both names, that is Mayer's formula and the second one is Fitrah's formula. So these both names you should understand, or you should remember these both names. So second one is Fitzgerald equation. Fitzgerald's equation. Okay. Now, so in this case, the rate of evaporation, it is equal to 0.4 plus 0.124 V into EW minus EA. Okay, so as you can see, the mainly it is that the rate of evaporation is proportional to difference between saturation vapor pressure and actual vapor pressure. So that is nothing but the Dalton's law. Hence we have written that point that these empirical formulas are based on the Dalton's law. So one more important things you can write it here, the units. So here in case of Mayer's formula, the units of EL, it is lake evaporation in mm per day. It is mm per day, whereas in this case EL, this is also in mm per day. So same. Okay, so EL value is same. Now the next one, this EW and EA, this we already know. This Km is the Mayer's constant. It is Mayer's constant. So the value of Km is 0.36 for large water. So these things are not important, but just keep this in your notes. So it is 0.36 for large water and it is for small and shallow water. Shallow water means shallow water bodies. Okay, large water body, small water body. So the value of K is like this. This U9 is called as monthly mean wind velocity. U9 is monthly mean wind velocity in kilometer per hour, kilometer per hour at 9 meter above ground, at 9 meter above ground. So that is the value of, that is the meaning of U9 here. Okay, so that's it with this. And here in this case, this EW and EA, this you already know, only the V thing is different, and this V stands for the same thing. Okay, that is monthly mean velocity in kilometer per hour. So these two are the important equations, or we can say these two are the important empirical formulas for the evaporation measurement. As I already told you, there is not much requirement for learning these formulas. However, okay, this I am saying it because I have not seen any question from these two equations. The questions are mainly from these names only, that this Mayer's formula is used for what? Evaporation measurement, precipitation measurement, or transpiration measurement. So for what it is used? It is used for evaporation measurement. Similarly, the Fitrah's formula. One more thing you can remember, that is the empirical formula are based on which law? They are both based on the Dalton's law of evaporation. So these are all the important points from the empirical formulas. Now we have completed the pan evaporation or the pan measurement, then empirical formulas. In the next video, we will start the analytical formulas.